This is Dr.SRIDHARAN from SNS College of Technology. In this lecture, we are going to see about the introduction to nanochemistry. Basics of nanochemistry covers nanotechnology, nanoscience, nanochemistry. Nanotechnology is a design, fabrication, characterization and applications of materials at nano level. The range from 1 to 100 nanometer and converting them into useful applications like devices, the fabrications in the car industries and devices and electronic gadgets. Nanoscience is a study of phenomena and the manipulation of materials between molecular and nanometer size. In nanochemistry is defined as the study of phenomena and manipulation of materials at atomic, molecular and macromolecular of nanoscales. So distinction between nanoparticles, molecules and bulk materials. Before going to discuss about the nanoparticles and their advantages, you should know about the molecules and bulk materials. The size of the nanoparticles are less than 100 nanometer in diameter. Molecules are a range of picometer and bulk materials are large in micron size. The nanoparticle is in between the molecules and bulk material. Molecule is a collection of atoms. Nanoparticles are collection of few molecules, that is less than 100 nanometer, but materials contains thousands of molecules. The surface area of nanoparticles is more than the bulk materials. Hardness of nanomaterials is 5 times more than the bulk materials. It is depends on the size and the shape of the particles. The strength of nanomaterials is 3 to 10 times higher than the bulk material. Nanoparticles possess size dependent properties, but bulk materials possess constant physical property. So mainly the nanoparticles, the size between the 1 and 100 nanometer, it has a lot of improvement when we are applying for the devices and fabrications. It enhances the performance of that technology. Whereas the bulk materials possess constant physical properties. And also one of the important applications for the fabrications and apply for this kind of nano coating to prevent the corrosion. It is a corrosion resistance of nanoparticles is more than the bulk materials. Hence, localized corrosion in nanomaterial is stopped. Behavior of bulk materials can be changed but cannot enter inside the nanoparticles. Nanoparticles, due to its size, possess unexpected optical properties. For example, gold nanoparticles appear deep red to black color in solution compared to yellow color with bulk gold material. Zinc oxide nanoparticle possesses superior UV blocking properties compared to bulk material. The differences between the molecules, nanoparticles and bulk materials. The size of particles in the molecule size is much smaller. Nanoparticle size is larger than molecules but smaller than bulk material. Where bulk material size is larger than the molecular nanoparticles, that is well known. So usually we are make it for many applications in the form of bulk materials only. Then magnitude of considering particles few angstrom in molecule, 10 to the power of minus 10 to 10 to the power of minus 12 picometer, and nanoparticles like angstrom to nanometer, 10 to the power of 10 to towards 10 to the power minus 9. This is a millimeter, bulk materials, that is a millimeter. The next one, the number of constituting particles, 2 atoms for molecules, 2 to several thousands of molecules, that is nanoparticles. Bulk materials infinite. Electronic structure, that is a confined for molecule and nanoparticles, but bulk materials, there is a continuous. Then fifth one, it is geometric structure. In molecule, well defined structure and predictable. The nanoparticle also well defined structure and predictable. Bulk material is a structural, the crystal structure decides. Thank you.